Every computer understands one native language, binary. It is built from only 0 and 1. From these to symbols, computers represent everything they process. A browser, a game, or an operating system may look completely different to us. But inside the computer, each one is eventually represented as patterns of zeros and ones. Programmers do not write software as millions of bits. They use languages designed for humans, such as C, C++, Rust, Java, and Python. These languages provide names, functions, and structure. A simple Hello World program is much easier to understand than raw binary. We can read this C++ code and understand its intention. But when the code reaches the CPU, the processor cannot read words like main, count, or return. Source code is readable to us, but it is not executable by the CPU. So if the CPU understands only binary, who translates our source code? The answer is the compiler. It stands between human-readable source code and the machine instructions that a processor can execute. A compiler is a translator between two worlds. English can become Japanese through a human translator. In the same way, C++ becomes machine code through a compiler. The journey of a program has several stages. Source code enters first. The compiler analyzes it, transforms it, and produces machine instructions. Then the CPU receives those instructions and executes them. Without a compiler, every programmer would have to write software directly in binary. Modern software would be almost impossible to build. The compiler lets programmers focus on ideas instead of millions of zeros and ones. So remember the central idea: a compiler translates source code into machine code, and the CPU executes the result. Next, we will follow that translation step by step.